My name is Mr. Worden. I've taught engineering, manufacturing, and physics for the better part of 8 years. I'm currently working on a museum display about organic chemistry. In order for the subsequent videos about this project to make sense, I figured I would separate this topic into its own miniature video. The question is, how many atoms are in this glass of water? First of all, what is this? This is 422.84 grams of pure water. Coincidentally, 422.84 grams of water is exactly the water content of a pound of asparagus. In order to answer the question in the title, we're going to need to know a few things first, information that we can find in the periodic table of elements. We understand that water molecularly is H2O and looks like this. We understand from elementary school that water is composed of 2 small hydrogen atoms and 1 larger oxygen atom. We also understand that there are a lot of these guys in this glass of water. But how many are there numerically? Let's consider some things that we know. The atomic mass listed in the periodic table of our 2 elements in question represents the mass of this many atoms of that particular element. So, therefore, this many hydrogen atoms has a mass of 1.008 grams. Likewise, this many oxygen atoms, if we could weigh them, if we could take their mass, has a mass of 15.999 grams. Water is 2 hydrogen atoms and 1 oxygen atom. If we add 1.008 grams of hydrogen and added another 1.008 grams of hydrogen and then added 15.999 grams of oxygen, we understand that we would end up with approximately 18 grams altogether if we took this number and 1 more of this number. Let's begin our calculations. We are starting with 422.84 grams of pure water, H2O. How can we convert from grams of water into molecules of water? Remember, we know that this many molecules of H2O has 18 grams. Let's use that information to our advantage. The first fraction I'm going to write represents that 422.84 grams of water is equal to 1 container. Right? I've got my container here, and it has this much water, so I've got this many grams per container. Secondarily, my second relationship is going to represent how many molecules are in 1 gram, right? Or are in 18 grams, excuse me. I've got 422.84 grams, and if I know that 18 grams is this many molecules, then I should be able to use both of these pieces of information to figure out how many molecules are in the container. How does that work? Well, conceptually, we multiply this like we multiply fractions. We multiply across the top, and then we divide across the bottom, okay? So how can we do that? Well, we kind of need to use our calculator, and you're going to see it on the screen here, but there's going to be a number. I'm going to put a number right here in post-processing, in editing. And then we are going to divide that number by 18. We're going to divide that number by 18 because 18 times 1 is 18. Wonderful. If we were to take this number and divide it by 18, we would end up with the following number. This number is the number of molecules in my container. Remember, this number represents some number of molecules. So my total number answer is equal to some number of molecules divided by 1 container. That's how I know the units for my answer. I have this many molecules in that container. That's how many molecules of water are inside that container of water. This is how many molecules are inside that container of water right now, approximately. We understand that each one of these molecules has 1 oxygen atom, which means that this number of molecules has this many oxygen atoms. And twice this number hydrogens, because there's twice as many hydrogen atoms as oxygen atoms. Inside this glass of water, there are this many oxygen atoms and there are this many hydrogen atoms, approximately. Thank you. Mr. Worden's Workshop is a 501c3 educational charity whose mission is building emotional and passionate intelligence through learning communities. Please consider supporting us following the links in the description, including a tax-deductible donation to our organization. Thank you, and remember to live the curious life.